All right, so let's get started here. So today we can all expect to spend about the next 30, 40 minutes maybe walking through the Blues ecosystem. We're going to talk about what we at Blues are about, the problems we're helping to solve in the world of wireless IoT, and most importantly, how we help to solve them. Quick introductions. My name is Rob Lauer. I'm Director of Developer Relations here at Blues, but far more importantly with me today is TJ Van Tol. TJ is going to provide a brief demo on setting up a Blues starter kit and sending your first data to the cloud via cellular, Wi-Fi, LoRa, depending on whatever he's got on his desk today. And I always think it's useful to start with our mantra here at Blues. And while I'm not a fan of reading text directly off of slides, I'm going to do so quickly here. So the quote is, "Complexity kills. It sucks the life out of developers. It makes products difficult to plan, build, and test." So this idea of complexity kills is really in our DNA at Blues. It is our goal to make developers' lives easier. And I think that's pretty easy for many of us to relate to, right? When we're adopting these new or maybe unfamiliar technologies, we want them to solve our problems, not make our lives more difficult. So hopefully you see this thread of simplicity kind of run throughout our time today and hopefully during your journey with Blues as well. So in our limited time, again, we have a very simple agenda. I'm going to do a brief overview of Blues, the Notecard, and Notehub, which is our cloud service. TJ is going to then provide more of a hands-on demonstration of how it all works together. And as you have questions, as we mentioned at the beginning, please enter them either in the Q&A panel or the chat panel. Either is totally fine. After we're done talking at you, we'll take some time to answer some of the best questions publicly. We'll answer as many as we possibly can. All right, so who is Blues? What is this Blues thing? Well, if asked, I can oversimplify what Blues is about. We provide hardware and services to back up this message of making wireless connectivity easier for developers and more affordable for all. We are led by former Microsoft Chief Software Architect Ray Ozzie. Ray is well known for starting up Azure at Microsoft, and back in the day was a key figure at Lotus. And if that is our core mission, how do we make this all happen? Well, I would say one of our main focuses is on security. So securing data from the moment it's acquired by a sensor all the way through to landing on your cloud application of choice. And we'll hit on this a little bit later. All of our hardware solutions are also low power out of the box, as low as 8 microamps when idle for the cellular note card. We're also very much a developer-focused company. Our developer experience is a top priority, and I think you'll see that play out a bit with our pretty elegant and easy-to-use JSON-based APIs. And finally, you'll hear this term wireless harmonization from Blues. What we mean by that is all of our hardware is swappable in terms of the physical connectors and the developer APIs. So you can really start building with Wi-Fi. You can deploy with cellular, or you can even have different radio access technologies in the field that are all using the same firmware code base. And that last point is really critical for us because in this magical world of wireless harmonization, we think that choosing the radio access technology should be a deployment time decision instead of a development one, right? So you can develop a solution, and then when it comes time to deploy, then you're making the choice of cellular, or Wi-Fi, or LoRa, or using a satellite add-on that we have as well, all based on the specific needs of the actual destination or destinations that you are deploying to. With that, let's introduce some products here. So this is the Notecard. This one in particular that you see is a dual cellular and Wi-Fi IoT device. TJ is holding it up there. It does come prepaid with 500 megabytes of data and 10 years of cellular service. That's all baked into the cost of the device, just a one-time cost. There's no subscription fees. There's no monthly SIM fees, no minimum data fees, nothing like that. But the Notecard, the hardware is only half the story. The other half is our cloud service that we call Notehub. And the two work together to form what we call a device-to-cloud data pump. In practice, what this means is developers will buy a starter kit, hook up one or more sensors to it, start reading data with their host microcontroller, and then deliver that data securely over cellular to Notehub. And then Notehub is going to route that data to your cloud. So to be clear, Notehub is a cloud service, but we're not trying to create a platform that locks you in. We exist to help you to connect to your platform, be it a big cloud like AWS or Azure, or maybe it's an IoT platform like a Datacake or UbiDots. So we're trying to help solve this really messy middle piece of connectivity, if you will, so that you can easily and securely connect your devices to your cloud applications. Now, there's a lot of note card options depending on the radio access technology, the RAT that you want to leverage. The good news is they are all swappable again in terms of both the physical connector and the APIs. We start with the cellular only note cards. If you look closely, if any of you are familiar with what Blues' history, our cellular ones have traditionally been on a green PCB. We have a new line of cellular only note cards that are black PCB, so more about these later. There's also a new-ish lower cost Wi-Fi only note cards. This is only $10. There's also a another new-ish LoRa only note card. This is also only $10. And another new, I like saying new-ish set of dual cellular and Wi-Fi note cards that allow for using either cell or Wi-Fi, obviously, or there's actually the coolest capability is the ability to fall back from Wi-Fi to cellular if you lose Wi-Fi connectivity. And finally, as mentioned before, we recently announced a new satellite add-on for Notecard called StarNote that allows for fallback satellite communications in supported regions. These get paired with a cellular and Wi-Fi note card or a cellular note card. Actually, let me rephrase this. You pair a StarNote with any note card except for the LoRa note card, and what it'll do is it'll fall back to satellite if either cellular or Wi-Fi is not available. Now, zooming in on the note card itself a little bit more, the note card is obviously the core hardware product that we offer. It is a low power system on module. The one you see pictured here is the Cell Plus Wi-Fi that measures 30 by 42 millimeters. The other ones measure 30 by 35 millimeters. It's a very predictable form factor. They all have the same M.2 edge connector for connecting or for embedding in your project. I've mentioned this a few times, but there are cellular, Wi-Fi, and LoRa variants. The cellular one does include a GPS module as well, and the satellite add-on, of course, that's coming soon. And on the cellular side, as mentioned, it does come prepaid with 500 megs of data, 10 years of service. You can top them up with more data as needed. The cellular one also comes with an onboard embedded SIM, but has the capability of, or allows you to add a secondary SIM as well, and you can switch between them if need be. And the API, so the way you interact with a note card, it's all JSON. So you're not using AT commands to manage your cellular radio. You're just using JSON-based APIs, much easier and equally as powerful. We also have supported SDKs available for a variety of popular languages and RTOSs. Now, again, everything is JSON in and JSON out with the Notecard API. As a quick example, if you want to get your Notecard's GPS location, which again is available on any of the cellular enabled Notecards, you simply send this request, rec equals card or rec::card.location, and it's going to return the requested location. Now, the rest of the APIs are set up very, very similar to this, very easy to read, very easy to understand. Now, if you're asking yourself JSON in C, it's kind of weird, maybe a little bit, but our libraries actually abstract that complexity out. So you are making JSON requests, you're parsing JSON responses from the Notecard using our C library. So that's really what the Notecard brings to the table. Just as importantly, though, you should know what you don't need when you choose the Notecard, and a lot of these apply to the cellular one specifically. You don't need your own SIM or mobile plan. As mentioned, the Notecard comes with an embedded SIM with global support. Likewise, when working with a cellular radio, you're not issuing AT commands. You're not manually managing cellular connections. You're not rolling your own security. So the Notecard, the hardware itself, includes an integrated ST-safe secure element with hardware crypto, with a hardware random number generator. There's also a factory installed certificate that's provisioned at chip manufacturer. For firmware updates, the Notecard and Notehub combine to provide incredibly easy ways to update both Notecard firmware, but also any attached ESP32 or STM32 host firmware, so you don't have to create your own custom processes for that. And of course, there's always some power management you have to do, but when you choose the Notecard, you rest assured that all the components on the Notecard itself are low power by default, as are the default configurations in the Notecard firmware. And as you'll see play out, especially when TJ does his demo, really sending data to your cloud endpoint is baked in. It's quite simple, but quite powerful. And on the certification side, the Notecard is FCC and PTCRB end product certified. So in most cases, you don't have to acquire separate certifications when using the Notecard at scale. Now, to make it easier to use your Notecard when you're prototyping or frankly, when you're ready to embed in a more permanent solution, we provide development boards that are called Notecarriers. So these let you snap in a Notecard and frankly connect it to virtually any solution you can dream up. The Notecard F, for example, includes a feather compatible socket, and TJ's got one there. The A model includes onboard antennas, but also has headers that let you hook it up to virtually any microcontroller you want. The B is a small form factor note carrier, and the Note Carrier Pi is a Pi hat for working with any Raspberry Pi compatible single board computer. The Note Carrier R for Arduino includes an eSlav connector for working with the Arduino Maker and Pro boards, very, very similar to the Note Carrier B, but has that eSlav instead of a quick connector. And next from SparkFun. So SparkFun has their own Micromod cellular function board that fits in with, of course, their Micromod ecosystem. And last but not least, Rack Wireless recently released Blues.1, which lets you use a note card in their WISP-Block ecosystem. Now, in terms of completing this whole device to cloud story, we get to Notehub. I would argue that the most important thing you need to know about Notehub today is it is a secure proxy that lets the note card communicate with the cloud. So Notehub takes care of all the security considerations, all the cloud connectivity, saving you, honestly, countless hours of setup and maintenance. Part of that savings comes from routes. Notehub lets you route note card data to any cloud application you want. Within Notehub, you can manage fleets of devices. You can, again, update both host microcontroller and note card firmware over the air. When I talk about security, especially on the cellular side, data is transferred off the public internet between Notecard and Notehub via private VPN tunnels. Data can be optionally encrypted as well. There's no certificate management, no key rotation required. The coolest thing about using the Notecard is it knows exactly where to go as soon as you power it on. Now, to help kind of visualize everything I just threw at you here, let me walk you through a quick diagram. When you choose Blues, you are bringing your microcontroller, your single board computer, your sensors, your programming language, or RTOS. We're not dictating any of this. You're then going to compose packets of JSON data that we call notes. You can think of these as events. These events are then queued. They're stored on the note card. And at a cadence you specify, it might be immediately, it might be once a week. They are securely synced with Notehub. Now, we don't want your data to live on Notehub. We want you to route that data to your cloud application of choice. Again, that could be a big cloud or it could be an IoT platform. Like some of our favorites are DataCake and UbiDots and Losant as well. And it's important to note that communication with the note card is bi-directional. So you can start on your cloud application. You can use that cloud application to send a JSON-based request to Notehub using the APIs we provide. Notehub will then securely deliver that JSON payload to a note card, maybe to a fleet of note cards, and the note card will then intelligently deliver it back to the host. So in this scenario, you can easily see how you can put together a remote control scenario or update fleet variables all remotely and all securely. So with that kind of high-level summary blitz, it's probably a good idea to switch over to TJ to see some of this in action. So I'll hand the controls over to TJ now.
Yeah, and I'll move things over. We did get one question about MQTT support, and the answer is yes from Notehub. I'll actually make a point to show that during the demo, and I'm just moving my camera over because I like to open by just showing some of the hardware because it's one thing to see it in slides. I think it helps to see it in person, although I've got a bit of a mess on my desk over here. I'll walk you through what you're seeing. So this line here is our note cards. And I've got the Cell plus Wi-Fi note card over here. It's a little bit larger because it has both the cellular modem and the Wi-Fi module on it. This is the note card Wi-Fi. This one's the note card Wi-Fi. This is the note card for LoRa. And then I've got a note card cellular creeping in over here. I've got actually the older version of the cellular. The new version, I'm told, is in the mail. I should have it pretty soon. So I'm pretty excited about that. So I can have a line of note cards that all looks the same. Now, around these note cards, and I'll clear them out so we have a little bit of space here, I have our series of note carriers. And the idea behind a note carriers is that it takes the note card and it takes this M.2 edge connector that you notice was on all of our note cards and gives you a convenient way to slot those in and provide some developer conveniences on top of it. So we've got the B and the R, which you can see are more or less the same thing. These are our small form factor note carriers. If you're just building something small and you just need access to the note card pins, or maybe there's slots for USB or LiPo batteries and a quick connector on this, it's kind of our simple way of getting started with the note card. We have the Note Carrier Pi. So if you're using the note card with a Raspberry Pi, maybe you want to use a Raspberry Pi and get cellular connectivity. The Pi Hat is really great for that. You slot it on top of your Pi with the stackable headers. You plug in your note card and you're good to go. We have the Note Carrier A. This one has built-in antennas. You can see some of our other ones. The note card has an external antenna on it. The A has built-in Ignion antennas on the side here. So that's another option. I've got a SparkFun one here. I'll show off the Star Note really quick just so you can see it. The Star Note is intended to be a companion to the note card. So it's going to work alongside it. I don't have, also in the mail is a board, some of our dev boards. Star Note is pretty brand new. And we're going to have some note carriers specifically for using the Star Note that are coming out pretty soon. But just to give you an idea of how you might practically start with the note card, we offer a series of starter kits. And the one I'm going to be demoing today is the Cell Plus Wi-Fi starter kit. The Cell Plus Wi-Fi starter kit comes with a Cell Plus Wi-Fi note card. It comes with a Note Carrier F, and it comes with a microcontroller we make here at Blues called the Swan. And the idea is with that hardware, you can take that hardware, and then if I move, I'm going to switch back over to me, and then also bring up my screen. Pick the right one. There we go. Once you have your hardware, you can head to our development center, which is available at dev.blues.io. And you'll see it has a link to buy the starter kits. And then if you click this Get Started button, you can see the two different starter kits we offer. So like I said, I'm going to be talking about the Cell Plus Wi-Fi starter kit. It comes with a Note Carrier F, the Swan, and the Cell Plus Wi-Fi note card. We do also offer a LoRaWAN starter kit. So this is going to come with 3 note card LoRas, 3 Note Carrier Bs, 3 batteries, and then a LoRaWAN gateway that puts it all together. Now, I'm going to be focusing on the Cell Plus Wi-Fi starter kit. You'll see that the steps that you have to take are somewhat similar. I'm going to try to point out where there are steps that are specifically happening for Cell versus LoRa as we go through this. But you'll see that each kit has a series of dedicated tutorials basically designed to help you get up to speed with Blues and the Blues ecosystem and to help you actually build projects or whatever it is you want to be building with Blues. So there are 4 tutorials here. I'm going to walk through the first one, and then we're going to quickly peruse through the last one just so you can get a sense of how all of this works. So we'll start with the Note Card Quickstart. Now, this Quickstart is like maybe any other tutorial you see on the web or for hardware or software. Other than this panel you see on the right-hand side of your screen, this is what we call our in-browser terminal. And we're using the Web Serial API that's built into Chromium-based browsers like Google Chrome and Microsoft Edge that actually allows you to directly connect to a note card over USB. So I'm going to grab, in this case, I'm going to use the Note Carrier B. As you can see from this dropdown, you can go through this tutorial with really any of our note carriers. Selecting a different one will just show you, if I scroll down here, the different steps that we walk you through to actually hook everything up. But once everything's hooked up, all the steps are exactly the same. So I'm going to plug in a Note Carrier B over USB. And then when I do that, I can connect to my note card. And this is a factory reset note card. So I'm showing you the literal first steps you would take with a new note card set up. And you'll see that our in-browser terminal is already telling us, sort of giving us hints at what we need to do, which we'll get to here in a second. Because if I scroll down just a little bit, the first thing we're actually going to run is this request called card.version. Now, first thing to point out is that the Notecards APIs are all JSON based. So the input, what I'm sending over serial here, this request of card.version, this is a JSON request. So JSON takes key value pairs and this curly brace syntax. This is what it takes as input. And the response is also JSON based. So this is a JSON object, an object with key value pairs. And in this case, card diversion is a pretty basic, it's like a hello world type of API. It's going to give me metadata about my device, things like my firmware version. It's going to tell me I have a cellular note card. I have the ability to do GPS because that's built into the cellular note cards as well. This request can be handy if you're building firmware that needs to work with multiple different types of note cards, so you can get an idea of what type of note card you're working. But basically, it's just intended for testing and doing this basic stuff like we're doing right here. To do anything with data, which is the main thing you're probably interested in using the note card for, your next step is to set up Notehub. So Notehub is our secure cloud service. Once you go there, you'll need to set up a free account, which I already have, and then create a project. So I am going to call this project Get Started, because that's what we're doing today. And I think I've already created this, so let's call it Get Started May. I built a lot of projects. I think our cloud team gets mad at me sometimes because I've got a mess. I'm a little bit of a Notehub hoarder. So I've got Get Started May here, and you'll see that setup is really easy. It's just that one button. And the one thing I need from my project is this identifier. We call this a product UID, and basically you can think of it as just a unique way of referring to this project. Because, and I'm copying this because my next step is if I scroll down a little bit, you'll see the next request, again, a JSON request that I need to run is one called hub.set. Hub.set is kind of the main like orchestration configuration thing that you need to run with your note card. You can provide this a number of different values. You can tell it how often you want to synchronize data going into Notehub and out of the note card. But the main thing you need to do, and what we're going to do right here, is just tell the note card which product you want to use. So in this case, I'm telling it I want it to use this Get Started May. And then the note card doesn't immediately do anything with this data because the note card by design is basically a queue. You queue up data on it, and then the note card synchronizes that data to the cloud at intervals that you can configure. So you can either provide this hub.set value, different values, like an inbound or outbound value saying, I want you to synchronize with the cloud every hour, every 5 hours, or whatever the case may be. That's usually how you would handle that for production situations. But we also provide a request that's great for especially demos like this, where you can just say, actually just take anything queued up on the note card and just instantly synchronize that over to Notehub. So if I run this, and sometimes the terminal starts syncs also for development purposes, so it's also running a sync with this note card, it's going to take that change. And then if I scroll back or switch back over to my project in Notehub, it's now made this association, and I can see this device listed now in Notehub. What happened though behind the scenes, this seemed very trivial, but if we step back and talk about what happened here, it's actually quite cool. This data was just sent over cellular, believe it or not, this association with this project. And I did this from a factory reset note card with 2 requests, hub.set and hub.sync, and just creating this one project. Meaning you didn't have to worry about the cellular modem existing. You didn't have to sign up for a plan with AT&T or Verizon or some other SIM company to make this happen. The note card just sort of silently handles all that for you. And that's the bit that's consistent with the note card across our radio access technologies. So if I were using a Wi-Fi note card, I would have had one additional step. There's a card.wi-fi request where I have to tell the note card which network to use, and then the note card operates over Wi-Fi. With LoRa, there's similarly, actually the steps for LoRa to this point would be identical. The way you work with data on note card is slightly different, but again, the mechanism is the same. You don't have to worry about the underlying LoRa technologies, how you're going to communicate with a gateway. All of that is built in and happens automatically, and that's sort of the magic, the value that we're providing with Notecard. Now, once you've made this association, so I have my device, Notehub knows, I've now got a connection between the physical note card that's sitting on my desk and my cloud project. And once I've got that association, I can start working with data. The easiest way to do that is with a request called note.add. Note.add, again, a JSON request. It's going to take a body. A body is a JSON object that can contain really anything you want. So in this case, we're going to pretend we have a sensor hooked up. We'll look at how to work with some actual sensors here at the end of this demo. But for now, we're just going to hard code some data just to see how this works. We're going to add a note, which again, a note is just a JSON object basically to the note card. And I'll go ahead and do that. And once again, this queues the data on the note card, but it doesn't actually provide a sync because we didn't give the note card, we didn't tell it what sort of mode to operate in, how often to sync. We'll look at how to do that momentarily. So we again have to run a hub.sync so that the note card takes anything that's queued up on it, this temperature and humidity, and pushes it up to the cloud. In more of a real project, you'd probably have a host taking sensor readings every so often, queuing them up on a note card. And depending on your situation, if you're not worried about power, if you know you're going to have mains power, you might want to put the note card in a continuous mode and just let it push data up as soon as it has it. If you're running on battery power, you might configure the note card to say, actually queue up the data whenever, but only synchronize that to the cloud because firing up the modem is the thing that's going to take up the most power at a far less frequent interval. So you got options for how you want to configure the note card for what you want to do. The note card is syncing up data. So what I can do is go into my events list, and you'll see that this data.qo, this event pushed up, and it has my data here. I can also go in, so I can view the event. I can view the body of the data, which is what I put in the note, which in this case is just the humidity and the temperature. I can also look at the full JSON object that captures a bunch of metadata that might be useful if I'm building stuff around this project. Each event gets a unique identifier. It's going to tell me which project it's in. It's going to tell me which device. It also picks up different location stuff. So in this case, I'm using the closest cell tower to me, which is apparently at this location. If you configure the note card for GPS, which you can do with one command, these requests can also be associated with a GPS coordinate. If you have a cell plus Wi-Fi note card, you can use Wi-Fi triangulation along with a note card, which is really, really powerful. And that can also be used for location as well. And that metadata will get associated with your notes. But essentially, the flow at this point is you're queuing up data on the note card, you're configuring an interval, and the note card somewhat magically knows how to push that data up to the cloud really, really seamlessly. And I'm going to pause for a second, Rob, just to make sure. I've been talking for a long time. Do we have any questions that have come in? Have I missed anything? Where are we at?
Yeah, there's been some great ones. Excuse me. There was a timely question, somebody asking if the hub.sync request returns a status, and I think you're probably just getting to that, but it's right on the screen here. So there's a hub.sync.status API that you can optionally use to see what the status is of the most recent sync. So you'll either give you a live view of what is currently happening, or in this case, it'll show you that 82 seconds ago it was completed. Yeah.
Yeah. So if you were writing firmware or something around this, because I should mention also that these requests this JSON I'm running that I'm sending over serial through the web serial API is the sort of the easiest way to get started with this. But we provide a series of firmware libraries that we're going to look at a minute, and your firmware can send these requests instead. And so in firmware, you might want to, if you're doing a sync and you want to know it's done, you could just run hub sync status in a loop. And basically you're looking for a completed flag to come back, which it should do, yeah, there in a second. So completed is like how many seconds ago it finished. So I hit this just at the right time. The sync had just finished. All right, the last thing I want to note, because this is just showing how to view the data, which we just looked at in a little bit. I do want to point out that the communication with the note card, Rob covered this in his slides, but is bi-directional. So if you're curious about this, we have a little tutorial here that you can go through. The basic idea, though, is if you go to one of your devices, which I'm going to go to my device here. Actually, I'm clicking too much. I'm going to go to my device here. You can add notes here and just send them to the device, and then the note card has APIs to pull them out. There are also APIs for doing this as well. So the note card has a HTTP-based API that you can use to queue up notes, and you can take that approach as well. All right, I'm going to go back to up here and the Cell plus Wi-Fi Quickstart, because that really is the first step of this, using the note card to send data. The next steps is, the first is we allow you to set up, we have a tutorial for setting up your microcontroller. We package a Blues Swan, which I'll hold up here real quick so you can see it. a microcontroller that makes it easy to get started with the Notecard. You don't have to use the Swan with the Notecard. You can use pretty much any microcontroller out there to work with a Notecard. We provide one just for a really easy get started experience. So when you're going to the tutorials, you'll want to set that up. The last tutorials, the first one is going to have you build a project using firmware and talk about how firmware libraries work with a Notecard and how to communicate with that. And we're going to go through that really quickly. And then the last one is going to talk about data. So taking data from Notehub and putting it wherever you ultimately want it to be. So let's talk through this. We're going to go into our what we call our sensor tutorial real quick for looking at how to work with firmware. So I'm going to go over and open up our firmware page. So if you go to the tools and SDKs section of our developer docs, you'll see all the firmware libraries that we offer. So we offer libraries for Arduino, for C, C++, Python, Zephyr, Go, TinyGo. We have some community-based ones as well. And really, these are libraries that make taking those JSON requests that we saw earlier and make it possible to do from a host microcontroller really easily, regardless of the language that you want to use alongside the Notecard. What I'm going to do is go to this tutorial's end state because we only have a limited amount of time today. I'm not going to walk through every line of code, but I'm going to swing over and show you what this looks like when you're done. I'll blow this up a little bit. Now, this one is Arduino code. It is C code. If you are not a C person, don't worry too much. I'm not going to talk through the intricate details. And actually, I would argue this isn't that hard to understand because if I scroll down, you'll see these same requests that we ran in the browser, just running in this code instead, using the Note Arduino, our firmware library, to make these requests really, really easy to run. So here's the hub.set request. Here's the product I'm going to be using for this project. For this project, I'm going to specify a mode. I want this in continuous mode because this is a demo and I want things to synchronize really, really quickly. Similarly, on my note.add, in this case, I'm doing a note.add, but I'm going to be using actual temperature data. The humidity data is actually mocked for this tutorial. The temperature reading is a real one. The Notecard has a temperature sensor built into it, which is what this reading is doing. But the intention of this example is just to give you a little more glimpse in of what a realistic project built with the Notecard looks like. So this one's using Note Arduino. All this code could be written in Python. You can run CircuitPython on the Swan. It can be written in some other language that runs on your own board. You can communicate with the Notecard using our firmware libraries. Now, this one is actually already running. So I held this up earlier, but I'll hold it up once again. So I've got it running on my Swan, and the Swan is in the Notecarrier F, and it is talking to the Notecard over I2C, and all that wiring is done for you by the development board. It's one nice thing about using our starter kits is there's no soldering. Everything fits together like puzzle pieces. It's really quite easy to use. And so I push this firmware out to my device, and what you're seeing at the bottom here is my serial log of what's actually happening. So every 30 seconds, I'm doing a note.add. And because I'm in continuous mode and because I've got this sync flag, everything's going up instantly. It's just to make the demo really nice. You probably don't. If I'm building a temperature sensor that takes readings every hour, that's a much harder thing to demo. But this this data is getting pushed up. And if I go back to Notehub, because if I scroll down here, I did mention that I have way too many projects. Oh, I pinned this one so that I wouldn't have to scroll. I have this weather app that this firmware is tied to, and you'll see that this thing is connected. And if I go to my events view, I get this stream. You can see every 30 seconds or so, I have this data coming through. See my office getting slightly hotter. So I've got all the lights on and working in this. This is showing you basically the data flow. So this is similar to what we did in the browser where we're queuing up notes, but now this is happening in an automated way. The temperature readings are real readings that are coming from the Notecard. They're coming in an interval that I configured, in this case, every 30 seconds very quickly. But you could see how you could process this and handle this to maybe put this on a low power setting, plug in a battery, take readings every hour, set it out, forget about it, let it do its thing. And again, if we look at our firmware, the one magic thing is that there is no mention here. There's really nothing that talks about cellular. Again, if I provided a card.wi-fi request and I had a Wi-Fi based or a cell plus Wi-Fi no card, it would just work over Wi-Fi. With LoRa, this project would work with the addition of one thing. For every note I add, I have to configure a template, and our tutorials walk through exactly how to do that. But if I just configured the template, this firmware would also run over LoRa. You wouldn't have to worry about the underlying LoRa technology or LoRaWAN technology either. All that stuff just works as well. And that's the real power of the note card. Now, the last thing I want to cover, if I go back to our tutorial, so we talked about this is basically our tutorial for building firmware with a note card. I should mention that we also have ways you can configure this. Like if you're a really big Python person, you can go through this tutorial and see how to write firmware in Python as well. But I want to go back and talk about the last step of this that talks about working with data. Because the thought is that as cool as it is to see your data coming through in a list in Notehub, you might ultimately want this data in your database. You might want to do things like set up alerts based off your data. Maybe you actually don't care much about this data, but if the temperature gets above 24 degrees Celsius, that's a problem, and I want to send out some sort of alert. You can do all of those things with Notehub. In this tutorial, let me close this one. This tutorial will walk you through how to do this with a number of different platforms, or you can keep it basic and do things with just straight up HTTP or something simple like MQTT as well. And I'll show in here, because if I go to create a route in Notehub, you'll see all of our options. Here's our MQTT option. We had a question about that earlier. We put sort of the general protocols up here at top, and then some more integrated ways of sending data to like AWS, Azure, Google Cloud, the big clouds, some of alerting services. If you want to send SMS alerts based off your data, you can do that. If you want to get Slack notifications, which I personally like using, you can do that sort of thing as well with Notehub. Now, I have a route already configured using a platform that we like for building dashboards called DataCake. And one reason we like using DataCake is that the configuration is as simple as getting one URL. They have a built-in way of working with the Blues note card and setting that up. And because if you look at my events, you'll see that I'm already routing all of my data as well. So all of this data is going to DataCake. And this last tab, if you might have noticed I had open, has this dashboard up. So this is a really, really simple, there's not a whole lot going on here. A dashboard that I set up in DataCake that's just showing me temperature, humidity, the strength of my signal, and the voltage, which is quite high because I've got this plugged in over USB, and some simple charts over time. But I show this just to show how basically the complete data flow with something that is built based off of Blues. So we have the note card. The note card is getting sensor data. In this case, it's using the temperature sensor that it has built in. The host is queuing up those notes on the note card. It's queuing up that data. I can configure an interval for how often that data should synchronize. That data appears up in Notehub. I can keep it in Notehub if I want, or I can configure ways of routing that data. You can route all your data. You can also set up conditional routes. You can say, I only care about certain things. There's lots of different ways you can configure kind of every step in this process, because really what we're trying to do is just make connectivity easy. Take these things that are traditionally very hard. With cellular, you have to go through all the steps associated with cellular, AT commands, modems, SIMs, all of that stuff, and simplifying it. Same with LoRa, same with some of these other technologies as well. And we have another, if you want to see, I should plug our StarNote webinar. If you want to see how it all works with StarNote, we have a webinar coming up for that as well, which I'll drop in the chat. But Rob, I've been talking for a long time again. I'm going to bring up the StarNote webinar so I can plug this, unless you're going to do that.
I was going to do it, but yeah, go to town.
Oh man, look at that. Look at our SEO. I just had to
Start it. Wow.
Yeah. We're doing pretty good. All right, I'm going to put this in the chat, and I know you have more slides, so I'm going to let you take over for a
more
second.
Slides. There's also, it's important to know with the StarNote webinar, we are giving away 3 StarNotes to attendees. So yeah, just saying, if you're interested in it, might as well show up and be eligible to win one of those. Just to wrap up here really quickly.
Rob, you didn't give me permission to chat with everybody.
Are you serious?
Rob, he doesn't trust me. Gonna spam people.
Well, all right. We'll do that in a bit.
Okay.
And there's TJ's face again. Um, I did want to tackle really quickly what does it all cost. So just to be totally clear, the note card is a one-time purchase, and the prices do range from $10 for the Wi-Fi or LoRa note cards all the way up to, I think it's 69 is where it maxes out for the Global Cat 1. I would argue our most popular cellular note cards average around $50 or so. And as a reminder, all the cellular note cards do include 500 megabytes of data, 10 years of service with no monthly fees. On the cloud side, you can actually route 5,000 events from Notehub to your cloud endpoints for free each month. So we'll top you back up to 5,000 each month. Notes or events that you send to Notehub from a note card are always free. It's just the routing out that costs us money. Beyond 5,000 a month, you only pay for what you use, and that starts at $11 for 15,000 events. Those can actually carry over from month to month, and the per event prices go way down from there. And just to be triply clear here, we're not here to surprise you with hidden cloud fees or SIM fees or subscriptions. Everything's very upfront. We do have some subscription options for companies who are scaling with us. But for developers who are just getting started, we try and make this all very, very accessible. And just to wrap up here, I want to present what I'm calling the most important slide, just kind of in summary. Frankly, for Blues to be successful, we need to be able to demonstrate the value that I think we provide. And this is what I think are some of the biggest differentiators that we provide. I think we offer the easiest onboarding path for wireless connectivity, full stop. You can deploy with different radio access technologies without changing your code or changing your board design, for instance. They all share the same physical connector, same developer API. When you're looking forward, like for example, with 5G, you don't want to be caught in that inevitable 4G sunset, which hopefully is years away, but it is coming. Blues is thinking along these same lines. You can rely on us for the same footprint, the same connector, so it's easy to swap in new boards without missing a beat. Everything, of course, is low power by design. Again, our cellular note card only consumes 8 microamps when idle, which is less than the idle draw of a LiPo battery, for instance. And when looking in the future, your connectivity is guaranteed, actually. So even if Blues were to go out of business, which we're not, but if we were, you're not stuck because those 10 years of service are already established with our connectivity provider, so that never goes away. The very last thing I want to mention is that we also offer a set of 40 or more purpose-built IoT applications that we call the Blues accelerators. These are totally free, completely open source reference applications that showcase a variety of best practices, other use cases when using the note card. You can clone them, use them as you want. You can find them all at dev.blues.com/accelerators. And before we jump into Q&A, there's a few resources I wanted you to have. Visit again, dev.blues.com for all of our technical resources. We do have a cloud-hosted note card simulator you can use for free that lets you play around with the note card APIs. You can get your Blues starter kit. It's a global starter kit for $99 at shop.blues.com. And as TJ mentioned, be sure to join us at the StarNote launch webinar on May 29th, where we're going to be giving away 3 StarNotes to lucky attendees. And with that, we can kind of hop over to Q&A.
Yeah, there's a couple good questions. So Nicholas asked, I'll take both of your questions here. Do you have a fully typed API for TypeScript-based backends for your JSON requests and responses? So we have a JavaScript-based library. If you look up Notehub.js in our tools and SDKs section of our docs, it does not have full TypeScript support. That is, there's an open ticket in our Jira for making that happen. So hopefully soon, but there's a JavaScript-based API to make it a little bit easier to interact with the API. And then your other question about the Raspberry Pi cellular hat, does the note card expose itself as a cellular network modem, or is expected that you'll need to use a lower level library? So really all you have to do with the note card on the Pi is you have to enable I2C because that's off on the Pi by default. And if you look at our tutorials for going through with a Pi, we'll walk you through how to do that. But that's basically it, because then you can just communicate with I2C with a note card and start working with the requests we saw today. You can use the Python. I mean, you can send the data raw over I2C, or you more easily you just use our Python library. You install the Python library and you start working with Notecard, and it's that simple.
There was also a question earlier about how can you easily provision 100 or more note cards, because the process TJ showed obviously would get kind of cumbersome if you're doing this at scale. And there is also I can't remember if TJ mentioned it or not, but there's a Notecard CLI that you can use, and you can pair that with a .json file, which is just a text file with a series of JSON commands. So you can run with one command, you can run that script to provision multiple devices with the same configuration over and over. So it just means swapping in a note card, hitting a button, and running that through. So we make it as easy as possible to provision devices at scale.
It's a question about FCC compatible antennas. Is it the
Oh yeah.
antenna that needs to be? I'm not sure, like, because the note card is FCC compliant, and with the free, I don't know enough about antennas to answer you. There's a decent plug though. If our forum is a good place to ask, discuss.blues.com, our community forum. We keep an eye on that, and any questions that Rob and I don't know, we ping people at Blues that are more specialized that have answers to that. So we get help with that. Certifications is not my specialty.
Yeah, usually it's the radio itself that needs certification, but yeah, it'd be a good question to ask.
Yeah, I think it is the radio itself, which it is for the note card.
Yeah, there was a question answered. I'm gonna rephrase the question a little bit to just kind of clarify how the note card and Notehub sync data back and forth. Um, so TJ mentioned that you queue data on the note card, for instance. So you might be queuing 10 or 100 notes, for instance, or events, however you want to picture those. And Notecard will then, whenever it makes its next connection to Notehub, will sync everything at once. And if you want to be able to maintain an order of events that came in, by default, everything is timestamped with the timestamp of when the event was created, when it was stored on the Notecard, and also when it was synced with Notehub. And if you need to specify any kind of custom ordering, you can always append that in the body of the JSON payload that you're providing. So you can rely on the Notecard and Notehub, its own timestamping, or just create your own process as well. And the same goes for data that goes from Notehub to Notecard. That's also timestamped, and you can process it on the Notecard.
So one more about over-the-air updates. So we didn't talk about it here because we just have limited time, but one cool feature of the note card is it does allow you to update firmware over the air, and it can update its own firmware, and it can also update host firmware as well. So it's a pretty powerful setup. It's called Notecard Outboard Firmware Update if you want to check it out. The question though is about LoRa. The LoRa Notecard is the one that does not support over-the-air updates, and that's just because of the low bandwidth nature of LoRa and LoRaWAN. It's just not really possible at all to send enough data over the air to actually provide that. So with LoRa Notecards, it's just a feature that's not available.
Yeah, and I'm not familiar with Meshtastic, but the LoRa Notecard that we offer only operates on the Things network or the Things stack.
Yeah.
Yeah.
And then I think we have one last question. So GPS GNSS, do you already have GPS modems built into the cellular modem? Yes, the GPS for our cellular note cards and cell plus Wi-Fi note cards, the GPS modem is built in. It's part of the same thing.
Great. With that, I think we can end on time effectively. But yeah, if you have any follow-up questions, please, as TJ mentioned, head to discuss.blues.com. That's our forum. TJ and I are on there all the time, but more importantly, we can find smarter people to answer some of these questions as well for you. So feel free to hit us up with any questions.
Cool. And see you at the start of the webinar, which you're definitely loading up and signing up for
For sure.
as well. All right. See you, everybody.
All right. Thanks, everyone.